Welcome to the Engineering Update. I'm Casey Panetta, editor of ECN. In this week's episode, a laundry folding robot, a way to 3D print soft biomaterials, and insurance for your drone.
On average, it's estimated people spend 9,000 hours of their lives folding laundry. 9,000.
It's over 9,000! What, 9,000? There's no way that can be right!
That's 375 days of work. So what price would you pay to have a year of your life back? A new collaboration between Panasonic, 7 Dreamers, and Japan's largest home builder, Daiwa House, are hoping to do just that with their laundry folding robot, appropriately named Laundroid. The prototype was revealed at Japan's Combined Exhibition of Advanced Technologies trade show. The demonstration involved taking a t-shirt and tossing it into an automated opening in the center of the Laundroid. At that point, all we see is a blinking closed door, so we don't really know what's going on in there. For all we know, there could be a secret laundry folder hiding in there. But given the fact that it took 5 minutes to fold just one t-shirt, that might be unlikely. The machine actually uses image analysis to identify the type of clothing received, which then sets off the robotic processes required to fold the garment. It's estimated that a full load of clothes will take about 7 hours to fold, which is a really long time to fold a load of laundry that might normally take you 7 minutes if you did it yourself. But the idea is that you could set the machine before bedtime or in the morning before work, and voila, clean folded clothes. Pre-orders will begin next year, although no pricing has been released yet. I'm sure the price tag will be steep, but ask yourself, isn't buying a year of your life back priceless?
3D printing has made great strides in the medical community. It's been used to recreate missing parts of skulls, build a titanium rib cage, and even to create low-cost prosthetics. One thing scientists haven't been able to figure out is how to utilize 3D printing when the material is in a hard substance like titanium, metal, or plastic. This limitation has restricted the growth of potential for things like 3D printed organs or soft tissue. But all that could change with new research from the Regenerative Biomaterials and Therapeutic groups at Carnegie Mellon University. The team has demonstrated an ability to use consumer-level 3D printers to bioprint hearts and coronary arteries with a cost of under $1,000. Utilizing open-source hardware and software, the team was able to produce the bioprinted soft tissue from materials like collagen and fibrin by using a soft bath technique. Basically, they were able to print gel inside gel utilizing a technique called the freeform reversible embedding of suspended hydrogels. This allowed the researchers to avoid the issue that most 3D printers have when printing soft materials, with the big problem being that soft materials tend to collapse under their own weight. Unlike, say, a plastic prosthetic, which will gradually build its own support layer by layer, soft materials don't have that solid structure to lean on. This support bath material method works by printing one gel layer inside another. This allows the material to support itself and allows researchers to place each layer just right. After the translucent support gel has served its purpose, it's dissolved in body temperature water, leaving just the bioprinted living cells. There's no planned date for when this might be available, but the team will now be focusing on incorporating heart cells on their way to forming contractile muscle. The hope is that eventually this technique will allow researchers to 3D print hearts and help ease the pressure on the 4,000 Americans currently waiting for a heart transplant.
By 2025, US businesses will be buying 160,000 drones, or at least that's what the Association for Unmanned Vehicle Systems International predicts. With that many drones flying around, something is bound to go wrong. That's why AIG is now offering drone insurance. Drones are going to be a big deal for insurance companies for 2 reasons. First, they're going to help insurers get to accident scenes quicker to assess damage. And second, when commercial drones are someday legal to fly everywhere, crashes will practically be unavoidable. But even with current UAV flight regulations, we're still seeing a ton of drone mishaps. AIG launched a series of policies that are tailored to the unique needs of operators, whether you're a professional photographer or just a drone hobbyist. Plans will cover physical damage to the aircraft itself, including cameras and other hardware that it may carry, and there aren't any exclusions if something goes wrong with the onboard electronics. But more importantly, it'll provide third-party liability in case you crash your drone into someone or something else. The costs depend on what kind of coverage you're going for. Obviously, it's going to be more expensive to cover your custom-made drone carrying a professional camera than it is your DJI Phantom with a GoPro. So if you only fly your drone in your backyard, you probably don't need insurance, or at least we'd hope so. But for more serious drone operators, this is a great option. Hopefully now you can fly your drone with a little more peace of mind. That's all for this week's video. Be sure to check in on Twitter and Facebook and view past episodes at ecnmag.com. For the ECN channel, I'm Jamie Wisniewski, and this has been your Engineering Update.